In this demo video, we are going to be looking at a 4x4 tic-tac-toe game. The main difference is that we will be going against an algorithm to predict what the best moves are, all while the outer board is rotating anti-clockwise and the inner board rotates clockwise. Here we see the opening screen. We have several options: play game, infinite mode, which I'll get back to later, how to play, and quit. If we select how to play, it will give us the information and instructions on how to play the game. To go back, we just click enter. Next is the infinite mode. Basically, what this does is that after several moves, a certain random piece will get deleted. We can choose 3, which is the default, or 0 to disable. I'll choose 14. Let's start the game. Here we have the board and also the inputs on what to do to select each space. We see the robot has made its turn, and it has removed one piece because I made the infinite mode to be 14, so that after 14 blank spaces, one random piece gets deleted. Now let's try to play the game. Well, unfortunately, I lost, but here I am prompted with the option to play game or not.
I will explain the game mechanism behind our game, Twist Stack 4. So we got three structure. The first one is the game board, which will provide basic method for the game to run correctly. The second one is the robot, which is the bridge between the game board and a tree. The third one is a tree that will foresee the possible actions the player may give and find out the best solutions to the robot. So this is the variables and the function list that we use throughout our code. This is the game board, this is the robot, and this is the tree. So we make our board using the coordinate in a 2D array list. So this will go from 0.0 to 3.3. For the outer section, we use a link list from 0.0, we link it to 1.0 and so on until it makes a full circle. Same goes for the inner section, but it will go in anti-clockwise direction. And the way we store value is, first of all, for example, the user store value in 1.0, so the board will rotate after the user input or the robot input. It will rotate until this special case. When the value in the 0.0 is found, it will be stored in a temporary variable so it doesn't disappear, because this is the start of the coordinate, and it will be stored in the 0.1. Same goes for the inner section, but it will go clockwise, while the outer section will go anti-clockwise. And the way we check the winner is we just check if the horizontal line, the vertical line, the diagonal is the same. So the default is 1 equals to false, but once any pattern list is found that the whole line has the same chess piece, for example this line, the 1 will become to true and we found a winner.
The program will first generate a game tree using recursion. The game tree predicts all the possible movements of the future 4 steps. After creating the game tree, the program will check if there are any winning patterns in the bottom nodes, which is the 4th move using the function check ready to win self. For example, if the pattern of the bottom nodes matches the above pattern, it is confirmed that the one side is winning, hence a value will be assigned. 0.9 and negative 0.9 will be assigned to the winning patterns of the circle and cross respectively. Hence, we will use the two functions set preserving value and set aggressive value. For the set preserving value, the function will assume the player and the bot will take the best move when it is in the robot's turn. The program will assign the nodes with its minimum preserving value of its sun nodes when it's player's turn. In the case below, the program would receive the value of -1, 0, and 1 from the check ready to win self function for the bottom nodes. Hence, the preserving value will assign as follows, as from the bottom to the top. However, it is rare that the preserving value of the top node can receive a value of -1 and 1. Therefore, check aggressive value function will be responsible for giving the bot a move. For the set aggressive value function, the program would add up the aggressive value of its sun nodes as shown on the slides. Therefore, the nodes will receive a variation of aggressive values, where the smaller values indicates the more winning outcomes for the bot. Hence, the bot would take the move with the smallest aggressive value. If there are several moves with the smallest aggressive values, the bot would randomly pick one as its move.